The focus of Chapter 3, Section 1 is to graph quadratic functions and identify key parts of the graph. So graphs of quadratic functions, if you're given the quadratic function in quadratic form, this used to be called standard form. In quadratic functions, it's called quadratic form. Bottom line is it's f of x or y equals ax squared plus bx plus c. A cannot equal 0. In other words, you must have this portion of it. B can be 0, it would just be eliminated. C could be 0, it would be eliminated. But to have a quadratic function, you have to, at minimum, have an a value of anything other than 0. So when you go to graph it, you're going to identify some key parts to your graph. And again, you want to just know what they are. The vertex is going to be the highest or the lowest point of the graph. It's where the graph changes from increasing to decreasing or decreasing to increasing. And so it is either the lowest point here, or again, if it opens downward, it's going to be the maximum point. So the lowest point's the minimum, highest point is the maximum. And the vertex is going to be in the center of the graph, and you're going to have this imaginary line of symmetry going through your vertex. What that line of symmetry means is that's the reflection line. Basically, everything to the left of that line is going to mirror everything to the right of the line. So if you know a point on the left, you can mirror it across that axis line. And so it's very, very important or critical when you're graphing quadratic functions that you identify the vertex and the axis of symmetry as one of the first steps that you do. So if you're graphing an equation in quadratic form, which quadratic form is the form in the page before where it's the whole f of x or y equals ax squared plus bx plus c, okay, in that form, you're going to have to find the vertex from that form. So there's a formula for finding the vertex. Now you know that the vertex is going to have an x and a y value. Well, the x value of the vertex is found by the formula, the opposite of b over 2a. Now remember, here's b and here's a. So it's the opposite of that b value over 2 times the a value. Once you find the x value of your vertex, you're going to plug it back into the equation up here, and you're going to find y. Okay, so you're going to plug in x and find y. Now, once you have that, that's going to give you your vertex. You're going to go to your graph, and you're going to graph your vertex. Let's pretend your vertex is right here. Now you know your axis of symmetry goes through that. Step 2 is you're going to plot your y-intercept. Now, the beauty of the y-intercept is that in this form, the c value is your y-intercept. So the coordinates of your y-intercept are 0, c, whatever c is, plus or minus, right? But this would be like plus positive c or whatever. If it's a minus c, it's negative c. So again, you're going to plot this y-intercept. So let's pretend the y-intercept was here. Well, then you would graph your graph. And then notice if you went, let's say, 3 units to the left, you'd go that many units over here, and you would mirror it, and you would be able to do your graph. Okay? So most of the math required is in the math that's going to be required to identify the vertex here. Once you find the vertex, you can use the y-intercept and then mirror. So here they give us some examples, but notice there's no b and there's no c. So again, what that means is really that b is 0 and c is 0. So I know my y-intercept is at y is 0. Well, this is an origin question. Basically what happened here is that you had you have your parent function, the x squared, and all we're doing here is a vertical stretch to it. So where normally in your parent graph, when x was 1, y was 1. Here now, when x is 1, y is going to be 2. Your output is times 2 what the original would have been. And that's the graph of that. Over here, again, notice I have my parent function. Notice that this is a vertical compression or a shrink. and my graph is going to be fatter. So again, it's going to go through the origin. There's no shift left or right. But now when x was 1, y was 1, now x is 1, y is a half. It's going to be half of what it used to be. And you're going to see that the graph is a little fatter. My axis of symmetry for both of these is through the vertex. So it happens to be the y-axis, okay? And so these are very easy to graph. This is very repetitious, something that you studied back in Algebra 1. So this is a vertical stretch, and this is a vertical shrink or compression, and nothing else really seems to happen here. When I come over to this one, notice now I have a -4. Again, the negative is a reflection over the x-axis, so it flips, and then it's going to have a vertical stretch by that factor of 4, okay? So what happens again, I'm still at my origin. There's no B, there's no C, there's no shift. I'm still at my origin, and my graph is going to open downward. It's going to look like that. And my y value is going to be 4 times what it would have been before. So it looks like that. And again, so these don't require a lot of math. This here is going to be a vertical shrink or compression. It's going to be fatter than the parent. And this here represents the reflection over the x-axis. So my graph, again, is going to open downward. And instead of when x is 1, y being -1, it's going to be -1/4. My graph is going to be fatter. Okay, so again, these are pretty basic. These really shouldn't even be in this section because I think you guys have done this a lot. We're going to get to another form here, which is standard form. Now, this is a little confusing. This in Algebra 1, we called this vertex form. So just kind of get used to how it looks, right? So in vertex form, your equation looks like this, okay? And remember, we did this when we were describing transformations. We said, oh, remember that the H is your shift left or right, your K is your shift up or down, and A, again, is the same with the whole vertical stretch, vertical compression, opening up or opening down, meaning reflections or not. So your vertex of your graph, when you're going to graph these, is going to be the H and the K values is going to be your vertex, and your line of symmetry is going to be a vertical line through H. So it's going to be X equals H. So we're going to do a lot of work with these, okay? So instead of having to do mathematical calculations to find the vertex, well, guess what? The vertex is in the problem, which is why it's vertex form, even though they changed it to standard form here in this book. So, for example, this is in vertex form. How would I graph this in vertex form? Well, again, notice that my actual vertex is going to be HK. Well, my H value is -2, and my K value is -3. Now, you might say this is a +2. Why did I say -2? And remember that the H value is always opposite what it appears. You know that this is a shift left 2 units, if you remember from one of your assessments, and it's a shift down 3 units. So remember, the K is as is, and the H is going to be opposite what it appears, okay? And so I know my H is the opposite of +2, which is -2, and my K is as it appears, so it's -3. So my axis of symmetry is going to be X equals -2. So I come over to my graph. -2, -3 is my first ordered pair. It's my vertex. My axis of symmetry goes through it. It's the line of X equals -2. So I have to write it as an equation of a line. And then at this point, what I'm going to need to do is I'm going to need to find one additional point. So I'm going to find my y-intercept, okay? Now you might say, well, why are you going to find your y-intercept? Why that point? Well, it's really important that you cross the axis lines at the right point, and it's also that it's easy. Remember that my y-intercept is going to be the value of my function when x is 0. So it's just easy math to figure this out. Plugging 0 in for x makes my math super easy. So I get 4 minus 3 or 1. So when x is 0, y is 1. And so here is the right side of my parabola. And now I notice that from my axis of symmetry to that point, I went 2 units to the right. So if I just go 2 units to the left, I can just mirror that value, and there's my graph. So this is my y-intercept, and this is a mirror image of it. And then I have my vertex down here, and that's a perfect graph. My axis of symmetry is placed, my y-intercept is identified, my vertex is identified, and I mirrored it. And that's how I would graph an equation like this. Now here we're back to quadratic form, right? This is the quadratic form, and so we talked about how do we graph something in quadratic form. Well, again, we have a formula for this. We basically know that we take, again, we're going to identify our A value is 1, right? Our B value is -6, and our C value is -14, right? So now I know that my vertex has an x value of the opposite of b over 2a. So the opposite of -6 over 2 times +1. So 6 over 2 or 3. So my vertex is at 3 something. So now I have to find the y value of my vertex, and what I have to do is I have to plug 3 in for all the x values. So y equals 9 minus 18 minus 14 or minus 23. So that is my vertex, 3, -23. My axis of symmetry is the equation of x equals 3. So again, I come over to here. I'm going to change the my y-axis here. I'm going to make it go up by 4s. So 4, 8, 12, 16, 20, 24. And so I know that 3, -23 is around here. So that's my vertex there. My axis of symmetry goes right through it. And now I need to identify a point on the left or a point on the right. Now I can identify my y-intercept simply by looking at the equation. I'm really lucky because I know my y-intercept is the value of the function when x is 0. However, in this case, I don't even have to plug it in. If I did, notice 0, 0, it's just -14. But remember that we also know that the c value is the y-intercept. So I really didn't have to do the math and plug 0 in. I just know that it's the c value. So my y-intercept is at -14 here. So my graph goes something like that. And so now I'm able to mirror. I know that 3 units to the left of the axis of symmetry, I was at -14. So 3 units to the right, I'm also going to be at -14. It's going to be a perfect mirror image. And so there's my graph. Now, I oftentimes, we think about it, we kind of want to cross our axis lines at the right spot. And I just kind of eyed that. So one value that's really important that we find is if we can find the x-intercepts. If we can find the x-intercepts of the graph, then that's going to be helpful to us because I'm going to cross at a more exact point. The x-intercepts are wherever the y equals 0, right? The y-intercept is when x is 0, and the x-intercept is when y equals 0. So how can I find the x-intercepts here? Well, I'm going to take that same original equation, and I'm going to make the y value equal to 0. And I'm going to figure out, well, what x values would make that happen. So this is where I would have to, for example, consider factoring. I might have to factor here. And I notice, unfortunately, that this is not factorable. So unfortunately, to find the x-intercepts here, to solve this equation, all I'm really doing is solving a quadratic, finding my zeros or my roots. Remember, those are my real solutions to this problem. I'm going to have to use the quadratic formula. Or I could also use completing the square. So you can solve using any method. So I would have to solve by completing the square, right? Or quadratic formula. And you have to figure out which one you're better at. I will tell you that you're going to be using the completing the square a lot in this section. So you might want to do it. And this problem is perfect for it because notice that A is 1, which it has to be, and the middle term is even, which makes it much easier to use. Now, I'm not going to do it in this problem because it didn't really call for it, but we will practice that. Whatever values you get there, those are the x values you're going to plug into here. Okay, so now we get to another question. It says find the vertex, axis of symmetry, x-intercept, y-intercept, and graph. So now they give it to us in quadratic form. So this one's in quadratic form, and they want us to find all that information. So in this one, I know A is -1, B is 6, and C is -8. So if they want me to find the vertex in this form, I know my formula is x equals -b over 2a. So the opposite of 6 over 2 times -1 minus 6 minus 2 equals 3. So I know my x value is 3. And again, now I'm going to plug 3 into the equation to solve for y. I need to know the y value when x is 3 because that's going to be my vertex. So y equals -9 plus 18 minus 8, and I'm going to get y equals 1. So 3, 1 is my vertex. So right there, that's my vertex. My axis of symmetry is just x equals 3. So I know it's this line right here, x equals 3. My y-intercept, super easy to find, it's my c value. It's -8. Now we do write it as an ordered pair, so when x is 0, y is -8, and it kind of comes here. Okay, so this is my y-intercept, and my graph goes like this. Notice my graph goes down. Well, look at A. A is negative, which means it's reflected over the x-axis, so it makes sense that it opens down. And then I just have to mirror. So again, if I know that 3 units to the left of the axis, I'm at -8, I know that 3 units to the right, I'm also at -8. So this is my mirror image here. And there's a perfect graph. So I've graphed it, I've found the vertex, I've found the axis, and I have found the y-intercept. Vertex, axis, and y-intercept. The only thing I have not found is my x-intercepts. And that would have been helpful because it would have helped me figure out where exactly was that supposed to cross. Because I think I kind of crossed in the wrong spots. So when they want the axis, make sure once you find your x-intercepts rather, make sure you fix your graph to go through those points, right? So remember that our y-intercept is the value of y when x is 0. So our x-intercept is going to be the value of x when y equals 0. So if you notice, what you're doing is just solving a quadratic, which you've done many times before. You're solving it. You're finding the x values when y is 0. So I'm going to start by dividing everything by -1. I'm going to still get 0, but then this becomes positive x squared minus 6x plus 8. And I know that this factors to x minus 4 and x minus 2. So I know x equals positive 4 and x equals positive 2. So that means my ordered pair is 4, 0 and 2, 0. Again, it's the x value when y equals 0. So my x-intercepts are these. So this is the final answer that we were looking for. And if I go to my graph, you're going to see I didn't exactly cross at 4, and I didn't exactly cross at 2. So let me tweak this a little bit to make this more representative and more accurate. There's my x-intercept at 2 and 4, and there's my graph. And so now I have really done a great graph. I have my vertex, I have my x-intercepts, I have the 2 of them. And I have my y-intercept and my mirror image, and my graph is now complete. And I've answered all the questions I was asked to answer. Again, here's another one. I'm going to do the same thing. Again, this is in quadratic form. And I'm going to now do, I know A is 1, I know B is -4, and C is 3. So again, my vertex is going to be the x value is the opposite of B over 2A. So opposite of -4 over 2 times 1, 4 over 2, or 2. So my vertex is 2 something. Now I go to here and I plug 2 in for x. And I'm going to get 4 minus 8 plus 3, so I'm going to get -1. So my vertex is 2, -1. It's right here. That's my vertex. My axis of symmetry is going to go right through that. It's the line of x equals 2. So my axis is x equals 2. My y-intercept, again, super easy to do. It's the value when x is 0, but I know it's the c value, so it's 0, 3. So that's my y-intercept. My graph is opening upward, which makes sense because a is a positive number, which means it's going to open up. And so the last thing I have left to do are my x-intercepts. So this is going to be the value of x, right, when y is 0. Now, before I do that, let me mirror my graph. I know 2 units to the left, I'm there. So if I go 2 units to the right, I'm going to be there also at 3, and I'm going to do my graph. This is my mirror. So now this is perfectly graphed. But again, I want to make sure, am I going through the right spots here on my intercepts, right? So let me just double check and make sure that those are accurate. Probably not 100% accurate. So again, I go back to the original equation in quadratic form, and I'm going to set it equal to 0. So when y is 0, what is the x value? And again, this, thank goodness, is factorable. X minus 3, x minus 1. So x equals 3 and x equals 1. So my ordered pairs are 3, 0 and 1, 0. Those are my x-intercepts as ordered pairs. So my graph is supposed to go through 3, 0 and 1, 0. Not too bad. And so again, perfect graph. My vertex is identified. My axis of symmetry is identified. My x-intercepts are identified. My y-intercepts are identified. And my graph is clearly labeled. And that's a great answer right there. Again, more of the same type of question. Again, it's given to me in quadratic form. And so I know my A equals 2, my B equals 8, and my C equals 7. So once again, the x, if I'm going to find my vertex, I'm going to first identify the x value. X equals minus B over 2A. So minus 8 over 2 times 2, minus 8 over 4, or minus 2. And then I'm going to find my y value when x is minus 2. So I do the math here. 2 times 4, minus 16, plus 7. So 8 minus 16 plus 7, minus 1. So my vertex is minus 2, minus 1. My axis of symmetry is x equals minus 2. And my y-intercept comes from my c value. It's 7. So when x is 0, y is 7. So again, come over to my graph. There's my vertex. This is my axis of symmetry. Oops, nope, I'm on the wrong side of the graph. That's not good. So it's -2, -1 here. This is my vertex. Here's my axis of symmetry. My intercept is 0, 7. 1, 2, 3, 4, 5, 6, 7. And so there's my y-intercept. I'm going to mirror 2 units to the left. I'm going to also be there at 7. That's my mirror image. It shouldn't be a V. It should be a U, okay? And then I have everything pretty much labeled and everything. I just, again, need to identify my x-intercepts, which are really the solutions of this quadratic equation. So I should have 2 x-intercepts. Let's actually do the math here. I'm going to make the equation equal to 0, and I'm going to solve for the problem. So again, I try to think of numbers that multiply to 14 and add up to 8. Unfortunately, this is not factorable. So once again here, I need to decide, do I want to do completing the square or do I want to do quadratic formula? Since a in this problem is 2, I would probably avoid completing the square and I would probably do the quadratic. So I know that x is going to equal the opposite of b plus or minus. It's going to be b squared minus 4 times a times c, the whole thing over 2a. So negative 8 plus or minus 64 minus 56 all over 4. That's going to be minus 8 plus or minus the square root of 8 over 4, which is minus 8 plus or minus 2 radical 2 over 4. And if I simplify, I can factor a 2 out of everything. So I'm going to get minus 4 plus or minus radical 2 all over 2. And that's, if I keep it together, that's as simplified as I could go. If I separate them, negative 4 over 2 is minus 2, and then it would be square root of 2 over 2 like that. Either one, but I'm okay with either one. So that's going to be the x value. So it's negative 4 plus radical 2 over 2 and negative 4 minus radical 2 over 2. Those are my x values, and that's what these values are. I just, again, they're not exact and whatever. That's as good as you're going to get. But that's how we find our x-intercept. And then notice again, go through, make sure you list everything, and you're good to go. At this point, what we're going to do is I'm going to skip the next few slides. One talks about coming up with an equation. I'm going to do that at the end or in a separate video. Another one talks about your calculator, so I'm going to skip that. So I'm going to move on ahead at this point to slide 16, and then I'll do the other slides in either at the end or in a subsequent video. So if you're following along, okay, go to slide 16. Okay, so you're going to go to slide 16. So in slide 12, this should be the last slide you look at after you've done everything else in this video. You should come back here. And what we're going to do is we are going to find an equation, and we're going to put an equation in standard form. Okay, we know it's a quadratic function. We're going to be given a vertex and a point that the graph goes through, and we're going to be asked to create the equation that happens to have that vertex and goes through those points. And we're going to put that equation in standard form. And again, remember, standard form is this one, okay? So I'm going to show you how to do it on the next slide. We have two examples of this problem here, and you're going to find that it's very easy, okay? So again, they want us to put this in y equals a x minus h squared plus k form. So if you notice, we're going to need to know a, we're going to need to know h, and we're going to need to know k. Well, the vertex gives us h and k. So I know h is 1 and k is 2. Now what I don't know is a. And so how do I find a? Well, I'm going to come and I'm going to write this equation out again, right? X minus h squared plus k. I'm going to sub in already the h and k that I've got. So x minus 1 squared plus 2. So I'm subbing in the h and the k that I got here and here. And I'm going to use, notice now I have an equation that has now just a, x, and y. So what I'm going to take advantage of is this point that they gave me. They gave me an x and a y point that it goes through. So I'm going to sub that y in here, and I'm going to sub that x in here, okay? And I'm going to use those points because notice once I do that, I end up getting an equation that only has one variable, okay? And so I can now solve for a. If you notice, I just kind of been plugging stuff in, and I've been getting here to where I can get a all by itself, and a is negative 2. So guess what? Now I have negative 2 as well. So I have h, k, and a now. So now that I did all this work, right, I can now go back to the original equation, y equals ax minus h squared plus k, and I can plug in the k value, minus 2. I can plug in the h, and I can plug in the k. And notice that it is now in standard form. That's the equation in standard form of this quadratic function that has this vertex and goes through this point. Okay, that's how we create this. This is how we do it. So we'll do it again one more time down here. We'll start out with the basic equation. I like to write it a bunch of times just because I want to practice it, make sure I memorize it. Again, notice that the vertex, you already have the h value, it's -4, the k value is 11, and what you need is a. So I'll come over to here, y equals a times x minus -4 squared plus k, and so I know that this is x plus 4 squared plus 11. So now I'm going to take the x and y value they gave me and plug it in for this x and y here. So I'm going to get y of 5, x of -6, the h and k are going to stay there. And notice the only variable I have left here is the a, so I'm able to solve for a. So 5 equals 4a plus 11. Subtract 11 from both sides. I get -6 equals 4a. A equals -6 over 4, or -3 over 2. And so I have my a value. And so now again, I'm able to kind of write out the whole equation, right? X minus h squared plus k. I'm going to have the y and the x, the letters y and x have to be in my final equation, always, okay? I have to have y, I have to have an x. Those are the variables that are left. A will be replaced with -3/2. H will be the x, right? X minus -4, which is x plus 4, and the k is 11. And so notice the only variables left here are the variables that I have to have. I have to have x and y in the final equation. And so this is how we do this problem. This is the last skill for the section, and I think, now we've pretty much covered every single topic in these slides. The calculator topic will be covered at another time. So in slide 16, we're really going to start talking about how to go from quadratic form and how to transfer it over to standard form. So how to go from this form to standard form, which is f of x or y, right, equals a times x minus h squared plus k. So how do we do that? Well, we're going to do that by completing the square. Completing the square is the process that we're going to have to utilize to do that. And without going through all the letters, I'm just going to kind of walk you through that process, okay? Or like this list of stuff. Let's just go and do one. So in this problem here, it says put the equation in standard form. So again, the equation right now is in quadratic form, and they want it in standard form, ax minus h squared plus k. And so how do we go about doing that? Well, we're going to have to complete the square. So what that means is we're going to have to take the equation as it is. We're going to keep the x squared and the 6x together, and we're going to separate out of it or away from it the -3. We could add 3 to both sides and move it to the left and then move it back down the road, but it's just easier to get used to just moving it over, shifting it out of the way. And so remember that now that we do this, our a value is 1 and our b value is -6. Well, remember, the value that we're going to put here when we're completing the square is always half of b squared. So what I'm going to do is I'm going to take half of b, which is -3, and I'm going to square it, and I'm going to get 9. So I'm going to add 9 to this side. Now, if I'm adding 9 in that parentheses, I'm going to have to do something over here to kind of wash it out, right? If I had moved the 3 to the other side, I could add 9 here and add 9 over on the other side of the equation. But what I'd rather do is keep it on the same side. And so if I add 9, I'm going to subtract 9. Again, notice if I'm adding 9 and subtracting 9, in the end, they're a wash and they don't really change my equation at all. Okay, what they do, they don't change the value, but they do change the appearance. And so by doing this, look what happens. This here I can convert to x minus 3 squared, and minus 3 minus 9 is minus 12. And notice by doing that, I now put it in standard form, which is what they wanted. Now that it's in standard form, I can use this to find whatever information they ask me to find. So for example, in here they asked me to find the vertex. Well, the vertex is very easy to find in standard form. I know the vertex is HK, which means 3, negative 12. My axis of symmetry is going to equal x equals 3. Remember, it's in equation form. My y-intercept, I can find it using this, but what I would have to do is make x equal to 0 in the equation and solve for y. So since the y-intercept is readily available in quadratic form, I know the c value is the intercept. I'm just going to do that. So when x is 0, I know y is negative 3. And the last thing I need to identify is the x-intercept, right? And so the x-intercept, I'm going to make y equal to 0, whether I do it in the original quadratic form or I do it in the standard form. The standard form is the easier way, in my opinion, to do it. And so notice this is standard form. I make y equal to 0 because that's going to help me find my x-intercept. Usually we have two x-intercepts. I could be wrong, but it's usually going to give me two answers. So I'm going to add 12 to both sides. I'm going to get 12 equals x minus 3 squared. Now, I like to see the 12 on the other side, so I'm just going to do it that way, okay? And I'm going to take the square root of the left and the positive and negative square root of the right side. So x minus 3 equals positive or negative square root of 12. And I'm going to add 3 to both sides, and I get 3 plus or minus the square root of 12. Now, I can simplify the square root of 12 a little bit. I know 12 is 4 times 3, and I know that 4 has a square root of 2. So my x-intercepts are 3 plus 2 radical 3, and 3 minus 2 radical 3, and then 0. So that's the location where it crosses the x-axis. Again, you could also do 3 plus or minus 2 radical 3, 0, and you could lump them into this 1, okay, because I know that that's really 2 coordinates. And if I asked you to graph it, then you would graph it. So again, this one wants you to convert to standard form, which we did using completing the square. We then found the vertex, the y-intercept, the x-intercepts, and the axis. So make sure that you're checking everything they want you to do. Okay, so again, more of the same now. So again, we know standard form is a times x minus h squared plus k. So we're going to do it. So we're going to separate out this minus 7 from the rest of the equation. I know that to find my value here, I have to find half of b and square it. So it's going to be negative 2 squared, or 4. So I'm going to add 4 here, and then on the same side, I'm going to subtract 4. Because again, adding 4 and subtracting 4 is a wash. Now I'm going to rewrite this. Y equals x minus 2 squared minus 11. Now I put it in standard form, so that's the first question they asked me. Then I'm ready to go and do all the rest of what they want me to do. So my vertex is going to equal 2, negative 11. My axis of symmetry is the line x equals 2. My y-intercept, again, I can find the y-intercept at any time by I can find my intercepts by making x or y 0, but in this case, if I'm looking for the y-intercept, I would make x equal to 0 and solve. But again, since I started out in quadratic form, I know the c value is my intercept. So I'm just going to use the negative 7 and be done with that. So the only one I have to mathematically compute at this point are my x-intercepts. So my x-intercepts are found I have to make something equal to 0 to find an intercept. So my x-intercept is going to be found by making y equal to 0. So I'm going to make y equal to 0, and I'm going to solve for x. I'm going to start by adding 11 to both sides. So 11 equals x minus 2 squared. I can leave it on the left. It's going to be plus minus square root of the right. So I have plus minus square root of 11 equals x minus 2. And I'm going to add 2 to both sides. So 2 plus or minus the square root of 11 equals x. So my x-intercepts, I can do it as one thing. I know those are two values. Or I can separate it. 2 plus radical 11, 0. And 2 minus radical 11 and 0. But that's how I find my x-intercepts. And again, I double check and make sure that I found everything, and I'm able to graph this if necessary. Again, we're going to do one more here. Then we're going to get to a couple that have a little bit of extra stuff to it, so I want to make sure that we get to those as well. So first of all, they want me to put it in standard form, which again is ax minus h squared plus k. So I come over to here, and I'm going to isolate, or not isolate, but I'm going to kind of separate out x minus 5x and move the minus 4 over, okay? I know that I have to come up with my value for here and here. And the value that I'm going to do for completing the square is half of b squared. So that's 25 over 4. So I'm going to add 25 over 4, which means here I have to subtract 25 over 4. Since it's on the same side of the equation, I have to do opposites so they cancel each other. So now that I have that, I'm ready to continue on here. I'm going to set up my binomial. I know this is x minus 5 over 2. And this is going to be minus 4 is equivalent to minus 16 over 4. And so that's going to give me minus 41 over 4. And so this is my standard form that they wanted. Okay. Now that I have this in standard form, again, I'm able to solve for the various things. The vertex is the easiest. I know it's 5 over 2 and minus 41 over 4. I know my axis is super easy. It's the line of x equals 5 over 2. And my y-intercept, I'm going to grab it from the standard form up here, which is 0 minus 4. Okay. Now again, if I didn't have this equation here to get my y-intercept from, I know that to solve for the y-intercept, what I would do is take either equation and set x equal to 0. Okay, so I could either make this equal to 0 and solve, or I could make this and this equal to 0 and solve, and you're going to see that mathematically you're still going to get 0, negative 4. The x-intercept, in either one, I have to actually plug it in and solve and factor or whatever. So again, how you find the x-intercept is you're going to make the equation equal to 0. I could go back and make this equation equal to 0, or I could go here and make it equal to 0. If this is not factorable, which it's not, I probably will just do this one. Okay, so I'm going to do 0 equals x minus 5 half squared minus 41 over 4. I'll start by adding 41 over 4 to both sides. Basically, I'm isolating what's being squared. Then I take this plus minus square root of the left and the square root of the right. And I'm going to get plus minus the square root of 41 over 2. And over here, I get x minus 5 over 2. So I'm just going to add 5 half to both sides. 5 over 2 plus or minus square root of 41 over 2. And I could consolidate it to 5 plus or minus square root of 41 all over 2. So my x-intercept is 5 plus or minus radical 41 all over 2 and 0. Okay, and again, I could separate that to 2 if I wanted. You know, I know that this is 5 plus 41 over 2 and 5 minus radical 41 all over 2 and 0. Okay, either way. And there you have all the things that were asked for. So in this slide, we're going to bring up one last type of a little bit more complex problem, and we're going to do 2 examples of this. If you notice here, when I have this form, if I come into this one and I want to isolate, I want to complete the square, remember the process is to take the 2x squared and 3x and then move the 1 away from it and kind of complete the square. The problem is you cannot complete the square when a is anything other than 1. Okay, it has to be a positive 1. So I'm going to have to factor out a 2 from this little group that I just kind of created here. So that's going to make the x squared by the a value 1, which is good. But now I have to factor a 2 out of negative 3x, which is going to leave me with minus 3/2 x. And then plus 1 over here. So now when I come in here and I'm thinking, okay, I've got to complete my square. I've got to come up with this number, right, that I'm going to add and subtract on this side. I have to figure out what half of negative 3 over 2 is, because that's half of b. So I know half of b is negative 3 over 4, and I have to square that. So that's going to equal 9 over 16. So I'm going to add 9 over 16 here, okay? And I know that what you want to do is quickly subtract 9 over 16 here. But recognize that this 9 over 16 that's in this space is not just 9 over 16. It's 2 times 9 over 16. Notice that that 2 is being multiplied to everything in the group, okay? So 2 times 9 over 16 is 18/16. So if I'm adding 18/16 to this part here, then I also have to subtract 18/16 over here. And so I have to be very careful when I factor something out. I have to remember that I factored it, and it's going to alter this value over here, okay? Because if I just do 9 over 16th, I'm not subtracting the exact same thing, okay? So anyway, so now I'm ready to keep going. Now I've got 2 times x minus 3/4 squared, and then 1 is 16 over 16, so that's minus 2/16, okay? Or I can simplify it a little more. It's x minus 3/4 squared minus 1/8. Okay, that's the simplified version of that answer. And so that is my standard form that we wanted. And then from that, I can now get everything else. So again, my vertex is going to be 3/4 and negative 1/8. My axis of symmetry is going to be x equals 3/4. My y-intercept, again, I'm not going to do any math because I know back in quadratic form, it's going to be the c value. So my x-intercept is the only thing that I'm really needing to figure out. And again, I can make this equal to 0 here, or I can make, I can do it down, I can make this one equal to 0. So I'm going to look at the original 0 equals 2x squared minus 3x plus 1, because I think this might be factorable. A product of 2 and a sum of negative 3, that's minus 2 and minus 1. So I could actually factor this, and I think I'd rather do that than actually work with all these fractions in here. So I'm going to make that one equal to 0 and see how that works. Again, remember when I expand to 4, I have to group. So I'm going to get 2x, x minus 1, minus 1, x minus 1. So I know my factors are 2x minus 1 and x minus 1. So 2x minus 1 equals 0, 2x equals 1, x equals 1/2. That's one solution. And x minus 1 is 0, so x is 1, and that's the other. So remember, these solutions translate to when x is 1/2, y is 0, and when x is 1, y is 0. And there's my intercepts. So for this problem, because this was factorable, I just chose that method. I could have plugged it in here and solved it, but again, it's a little bit easier math, and I don't care which one you use. You have to convert it to standard form, but once you convert it and you have it in standard form, you can use either form to find the missing pieces that you need. And this is the last one of this kind with, again, another put it in standard form. Obviously, you're going to use completing the square. And this is another one that has that kind of that weird thing that has to be factored out. So I want to practice this one more time with you. So again, we're going to start by minus x squared plus 3x, just kind of shifting the 4 over and making room for that extra value, right? However, at first, we notice that the a value here is a -1, and I'm going to have to factor that -1 out, okay? So x squared minus 3x, and now I'm ready to do my completing the square. So again, half of -3 is -3 over 2, and when I square it, I get 9/4. So I'm going to add 9/4 here. But again, if I'm adding 9/4, right, I know that what I'm really adding, I have to remember that that's 9/4 times -1. So that's really a -9/4, which means this has to be a positive 9/4 because I have to have the opposites. They have to eventually cancel each other out, okay? So I have to remember that -1 I took out. So I keep going here. This is going to equal -1 times x minus 3 over 2 squared. And then a -4 is the same as minus 16 over 4. I want to give it a denominator of 4. And I'm going to get minus 7/4. So this is the equation in standard form. And then I'm going to draw and find my information from that. So the vertex, I'm going to take it from standard form. I know it's 3 over 2 and minus 7 over 4. My axis is going to come from this as well. X equals 3 over 2. My y-intercept is going to come from this one, this equation here. I know my y-intercept is the c value, so it's that. And then I have to do my, I'm stuck here doing now my x-intercepts. So I'm going to have to make y equal to 0 and solve. Again, I'm going to just look at this one up here and see if this is one that I would rather use the standard form for. If this is factorable, I definitely want to use it. So I'm going to divide everything by -1, x squared minus 3x plus 4. And I'm going to see if I can factor this. And I can't. Nothing multiplies to positive 4 and adds up to -3. So unfortunately, it's not factorable. So if it's not factorable, I'm going to use this method for this form for the x-intercept, because I think this form is easier when the other one isn't factorable. So I'm going to start by adding 7/4 to both sides, because it's going to cancel. So -1 times x minus 3 over 2 squared. I'm going to multiply everything by -1 or divide by -1. So I'm going to get minus 7/4. And over here, I'm just going to have x minus 3/2 squared. So I'm going to get rid of that -1. And then I'm going to take the square root here and the positive and negative square root here. Over here, I'm going to get plus minus the square root of -7 over 2. And over here, I'm going to get x minus 3/2. I'm going to add 3/2 to both sides. So I'm going to get 3 over 2 plus or minus the square root of -7 over 2. And I could clean this up, but you should start to see a little problem here, because -7 in the radical is really an imaginary number. It's I radical 7 over 2. So guess what? X equals an imaginary number, okay? The problem is, guess what? There is, remember that the x-intercept is where it's the real numbers where x, or where the graph, right? Where the graph crosses the x-axis. The graph crosses the x-axis. So guess what? There are no real numbers where the graph crosses the x-axis. We only have imaginary solutions here. So what this means is there's no x-intercepts. If I was to graph this graph, notice my vertex is at 1.5, -7/4. So let me just let's just say it's down here somewhere. Let's just make that my vertex, okay? And notice my graph opens downward. My y-intercept is -4. My graph goes like this. I mirror it, my axis of symmetry, whatever. Notice my graph, there's no x-intercepts here. It does not cross my x-axis at all, okay? So that's what it means. When you get an x value that's imaginary, it means that your graph has no x-intercepts, Okay, so that's kind of a special case to look out for, because it's not going to cross at an imaginary spot. So now I'm going to ask you to move to slide number 12, which is the last and final skill from this section. So we're going to go back to there.